All right, let's take a look at target 37, simplifying complex expressions. Now in this particular example, I'm going to show the first two, and then if you're ready for more of a challenge, I will show you the third one, which is simplifying the denominator or rationalizing the denominator. That is not a full expectation for all classes, so here goes. First one is just to simply multiply. This is a real numbered portion plus an imaginary number portion. This is called complex number. A complex number is made up of a real number, like we're used to -4, and then this imaginary part with the 5i. Put those together and it's complex. Now if we're going to multiply these, it's a lot like doing anything we've done with x's in it. We just use a generic rectangle and we multiply them together. So -4 plus 5i goes here, -4 plus 3i goes here. Then I multiply everything out and fill in the boxes. -4 times -4 is +16. -4 times 5i is -20i. And then this would be -12i, and this would be 15i squared. And then I just combine like terms. And so once I combine like terms, then I just put everything together. So I've got 16 minus 20i minus 12i plus 15i squared. Now, you do have to have an understanding of what I is. So we need to understand what I is and what it all works about as we're going to simplify this 15i squared at the end. So 16 minus 32i and then plus this 15i squared. Well, we need to have a foundation of I. And so if we start thinking about this, remember the definition of I, or the imaginary number, is the square root of -1. Now if I take that times itself, that's I squared. If I do square root of -1 times square root of -1, that's going to give me -1, right? And then after that, if I took I to the third, that would be this times that, so that'd be -1 times I, or -I. And then I to the fourth is a situation where we'd have an I to the second times an I to the second, because 2 times 2 is, 2 plus 2 is 4 for exponents, so -1 times -1 is 1. And then the pattern just keeps repeating every 4 numbers. So no matter what fourth number you're on, it always does the same thing. So example, if I went to I to the 8th, excuse me, not t, but I to the 8th, that would also be 1, because it's a multiple of 4. And it's just going to keep repeating this pattern over and over and over again. I to the 9th is 1 more than a power of 4, so that's going to start over, and that's going to be square root of -1, or just plain old I, as we call it. Okay, so here I've got an I squared. I squared is -1, so then this just means 15 times -1, which is -15, so I put a minus 15 right there. So then if I have 16 minus 32i minus 15, that's 1 minus 32i. Now, these are getting down to the practice of, do you know what I means and what's it stand for? Well, clearly, I to the 16th power. 16 divides by 4 evenly. So then I know that that's the same thing of whatever I to the 4th is. I to the 4th is 1, therefore I to the 16th is 1. Next, I to the 25th. I to the 25th is darn close to I to the 24th. I wish it was I to the 24th, because then the answer is divisible by 4, so the answer would be 1. But it's 1 more than it. So on my list, if I was here, I would just do 1 more than it, which brings me back to the top, which is just plain old I. So the answer to that then is I. Now 39. Dang, that's close. That's close to I to the 40th, but I'd have to go 1 backwards. So I go here on my list, and I go 1 backwards, and that's going to be -I. And then the last one, I to 100 power. Well, 100 divides by 4, and so therefore it's a multiple of 4. That's easy, so the answer is 1. So we really use this repeated pattern over and over and over again. The key to being able to figure out some of these things is this. And then the other thing is being able to do, well, if I'm going to multiply 2 things together, I can do that. And then, you can check these on your calculator. You can set your calculator. If you push the mode key in your calculator, you push mode, and you get it over to this mode right here, which is A plus BI, complex number form, where you have the real and the imaginary portion. Then it's going to work for you, because I can just type it in. In parentheses, I can type in, -4 plus 5, and then second I is above the decimal point, and then times, and then I can just go -4 plus 3 second I, which is above the decimal point. Push enter, and there's your answer. and your answer is 1 minus 32i, just like it shows here on the screen. So you can type in the i's and let the calculator do the work also, but if you try to do it with the powers, like if I had to do I to the 39th power, it really doesn't, well, it's 36, whoops. If I do I to the 39th power, it really doesn't cooperate as much because it tries to show you negative 1e, negative 13. It does show you a negative I back here in the ending, and that was the answer to that. That negative I is a part of it. There is a pattern in the answers here. If you want to know what that pattern is, you'll need to talk to your teacher. Now, for the challenging part of this, or the challenge section, a little bit extra. This is a complex number. It's an irrational denominator. It's an imaginary denominator, I should say. So we need to get rid of that. So we're going to have to multiply that by its complex conjugate, its opposite. So we do 1 plus 2i on the bottom to get rid of everything. Well, the same thing, then we'd have to multiply the top by 1 plus 2i, and therefore that would rationalize this denominator. So then I'm going to multiply these out, and if I step in with my calculator here to make these calculations faster, then that would be 2 minus 5i times 1 plus 2i. Then I get the top being 12 minus i. So I can just go here and say the top is 12 minus I. And then on the bottom, I would just go with, okay, that ain't bad. I just got to do 1 minus 2i times 1 plus 2i. And I get 5. So my denominator is 5. So it's 12 minus I over 5. And you now have a rational number down here. And that is an eligible fraction. Then it's okay to leave it in that form. The key to this strategy is just kind of learning, when you're using what tools and what powers of I. But this can be figured out by a generic rectangle. It can be checked on a calculator. And these, you're going to be using that repeating pattern of I to the 4th power.